we want to find all the angles between negative 800 and 800 coterminal. So this was one of the definitions we learned yesterday, yesterday. It's like, sometimes you say yesterday and it was Monday, and it's like, but no, it's good. It's Wednesday. Yesterday, coterminal means that it ends in the same place. So if I draw 85 degrees in standard position comes from the positive x-axis and ends right there. I need to make a list of all the angles between negative 800 and positive 800 that end in the same place. Okay? Well, how do I end in the same place? If I went all the way around once and ended in the same place, that would be coterminal. How do we figure out what that is? Well, we could start with our 85, and then all the way around the circle once is adding 360 degrees. So the green one will be my 85 degrees plus 360 degrees more. Does that make sense? And so if I add those together, I'm going to get 445 degrees. If I go around, oh, I'm going to accidentally hypnotize you guys again. If I go around twice, does that make sense that that purple one would be 85 degrees plus 360 degrees once plus 360 degrees again? But when I add that up, I get 805 degrees, which is already past the 800. So the only positive ones will be the 85 and the 445. But we also want to look at some negative ones. If it's in standard position and starting here and going in the negative direction, that would look like this. That would be the equivalent to say start at 85, but go around one whole time in the backwards directions, which is subtracting 360. So this red angle starting here and ending at the same place would equal negative 275 degrees. If I subtracted 360 again, can you see that every time you add 360 to an angle or subtract 360, you're going to end in the same place? Because if you're pointing in one direction, 360 means around, you would end in the same place. So if I did another one, starting with negative 275, and I subtracted 360 degrees again, I would get negative 635 degrees. Can you see that if I subtracted 360 again, I would be past negative 800? So if we wanted to make the list, because it said to determine the measures of all the angles between negative 800 and positive 800, you'd have negative 635, negative 275, positive 85, and positive 445. This would be the list of all of them. The diagram is really messed up right now with all of those colors and circles. But I didn't sketch the last negative 365. I'll underline it in black. Can you see that that would be once around, twice around? Hoy, there we go. Officially hypnotized again. You still like math. You still want to do your math homework. Well, because you were hypnotized yesterday. I told you this once. I know, but now that I snapped you back in, now you remember it. So, yeah. Wouldn't that be cool? That'd be so awesome. If I could actually, like, you just come to class, get hypnotized. Or wouldn't it be cool if you just come and you're just like, okay, put your hand on here, download this year's math, and you're like, okay, I got it. I'm good for the year. I know, it'd be so much faster. I know, we're working on that. Okay? But people get nervous if you start, like, inserting microchips with COVID vaccines or stuff like that, then they get mad. Okay. All right. Part B. Oh no, this could take us a while. We did the ones between negative 800 and positive 800. And part B, they want us to list them all. See, this is a problem. There's going to be an infinite amount of them. We're going to be writing forever. Because it says list all the ones that are coterminal. So that means we would have to take 445. To do the next one, we'd add 360. And then take that one and add 360. And take that one and add 360. And take that one and add 360. Forever. This is problematic because I don't think you guys have forever, right? So mathematicians sometimes say we want to write down an infinite amount of things. How do we do that? And the way that they decided to write that is they said, well, we'll make a formula instead of writing them all down. What would that formula look like? Well, all of these numbers, if I kept writing them, they all start with 85 degrees. And then you can add or subtract 360 degrees as many times as you want. So the way they show as many times as they want is they say times by, and they choose some variable. They like to use the letter k in this situation. Times by k, and then they tell you, but k isn't any number. You can't add half of 360. But you can add 1 360, you could add 2 360s, 3 360s, 4, 5, 6, 7 360s. Or, what did we do when we went the other way? You could also subtract 360s. So then k has to be a positive or a negative whole number. What do we call those numbers? Integers. Positive, negative whole numbers are integers. Do you remember from previous years the symbol for integers? The R would be real numbers. Integers with a Z. So that means, no, I haven't seen it. Yes. So this means the integers. Like the real numbers, you remember, you've seen this one, right? XER? We did it with the, right? You remember that one. That's all real numbers. If you do something EZ belongs to the integers, it's just positive and negative whole numbers. Why is it Z? From the German word Zahlen, which means numbers. In the United States, they sometimes use I because they don't like to use anything but English. But internationally, in mathematics, we would use Z. Okay. Questions for practice. You can circle questions 4 and 5. Does this make sense? If I wanted to find negative 635, then k would be minus 2. That would list that one. And so we create a formula which finds them all, which is way better than taking the time to list them all. Because you'll just be stuck on that for the rest of your life. Would you give up your mortality? In other words, would you choose to become immortal if you were forced for the rest of your life just to write coterminal angles down, and that's all you would do forever? That would be, there we go. That would not be a very good life to live.